Hello, I just wanted to run through some cool things that we can get from the unit circle. So the unit circle is a circle with a radius of 1. And here I have a triangle drawn, this guy, this little black triangle here. And since the radius is 1, any line from the center directly out to the edge of the circle is going to have a radius of 1 or a length of 1. And here we have a nice little radius and its length is 1. The other thing I drew here was just some information about Sohcahtoa. And this is the mnemonic device that we use to remind us how to find the trigonometric ratios of sine, cosine, and tangent in a right triangle. So to compute the sine of theta, let's look at our triangle. I've got the sine of theta is equal to opposite over hypotenuse. So theta is my angle that I use in order to refer to the sides of the triangle. So across from theta, I have opposite. And then the hypotenuse is always going to be the radius, or this little piece here, which is 1. So in order to rewrite this in terms of the information I have on here, I would say that the sine of theta is equal to the opposite, which is just the opposite, over the hypotenuse, which is 1. And we know that anything over 1 can just be rewritten as the sine of theta is equal to the opposite triangle length. If you'll notice, the opposite triangle length and sine of theta are one and the same. So I'm just going to rewrite or rebrand this side as the sine of theta. Okay, let's do the same with cosine. Let's look at cosine of theta. So on the triangle, the cosine of theta is going to be the adjacent triangle leg over the hypotenuse. The adjacent triangle leg is the adjacent over the hypotenuse, which is 1. So I could just rewrite that as the cosine of theta is equal to the adjacent triangle side length. So if the cosine of theta and the adjacent triangle leg are one and the same, I can just rename this guy cosine theta. Cosine of theta. So now we have 2 lengths on our triangle. This piece here is the cosine of theta length, and this piece here is the sine of theta length, okay? So if we wanted to write the tangent of theta, we go to theta and we look for the opposite side length over the adjacent side length. So that would give me the sine of theta over the cosine of theta. And this is a big important piece of information. So just write that the tangent of theta is equal to the sine of theta over the cosine of theta. Go ahead and put a little box around that because that is super important. Okay? And so that's why when we're looking at the unit circle, I'm going over cosine, and that is on my x-axis, and I'm going up sine, and this is on my y-axis. And that's why for any point on the unit circle, x is cosine and y is sine. So I can write any point on the unit circle, right? Like any point like this guy, right? As cosine of theta, comma, the sine of theta. Because look, cosine is the x and sine of theta is the y. Okay, so go ahead and write that up here. This is the cosine of theta, the sine of theta. That is this point right here. And I can also use the unit circle to derive a very useful Pythagorean identity. So think about the unit circle in terms of the Pythagorean theorem. Using what I have drawn over here, I can say that why is he so skinny? Hold on. That the Pythagorean theorem, using the triangle that we drew over there, right? So something that looks like this, would be a squared plus b squared equals c squared. You guys have been learning this since 7th grade, right? You're experts here. So now let's put it in terms of the triangle that we just learned about over here, okay? This side length here is sine of theta. This side length here is cosine of theta. And c is 1. So if I substituted, let me move this over a little bit, scooch. If I substituted the values for my triangle here into the Pythagorean theorem, I would get sine of theta squared plus cosine of theta squared equals 1 squared. So in trig, to show the difference between like something like this, sine of theta squared, and sine of theta squared, mathematicians will always write something like this as sine squared theta. And that's how you say it, sine squared theta. Okay. So we're rewriting this guy as sine squared theta plus, same idea, cosine squared theta equals 1. And this is a big, awesome Pythagorean identity. And we are going to use it so much. So make this something that draws your eyeballs to it, because you're going to be using it a lot. Whoa, very exciting. The